All right, we're looking at A11 today. We're doing a worksheet on solving quadratic equations by graphing, and there's a couple different parts to this worksheet. So we're starting off by putting equations in standard form. One of the things I had been asking you guys to do is when you put it in standard form to keep the ax squared positive. You don't have to do that. We will be doing that later when we get into factoring, but for now, we don't have to do that. I want to look at number 3 with you. So I need it to be 0 equals, we have ax squared plus bx plus c. So it has to go on the order x to the second, x to the first, and then the constant. So in number 3, I am going to cross the line, change the sign. So I'm going to bring this 10 over since everything else is over here on the right by subtracting 10. That's going to make that 0 on the left. And when I go to subtract the 10, I want to put it with the like term. So it does not pair up with the x or x squared. It pairs up with this -3. Now, before I just write this, I do want to put it in order. So I want my x squared first. Please pay attention to the sign. The negative sticks with the x squared. So first is going to be a negative x squared. Then will be my term with x to the first, which is positive 4x. And then my constant, which I'm going to piece together, -3 and -10, which adds up to a -13. I noticed people making mistakes here, missing their signs, ignoring signs, and then their graphs were off. So this is my answer. I'm fine with that. Okay. Now, if you wanted to keep the x squared positive, you could multiply both sides by -1 or bring everything over. So the other option you might see as an answer, if we switch all the signs or switch it to the other side, we'd have a positive x squared. We'd subtract the 4x, and we would add the 13. So either answer is acceptable. Do you see that all the signs are the exact opposite? That's the same thing. Now, if we had a y equals, we would leave it alone. We can't just switch signs. All right, so this is multiplying both sides by -1 or bringing everything over to the left. All right, now, if you look at example 5 and 6, you are determining which is equivalent to this. And the hint is to put this in standard form. That way everything's the same. So to put this equation in standard form, I'm going to subtract the 3 to 0 it out. So I get 0 equals, I get my positive 2x squared, my positive x, and I'm going to subtract the 3 and pair it with its like term. So I would have -11. So this is what I want to compare everything to. Now, I don't have to do any work on number 5 because it's already set equal to 0. Do I have the same equation? Positive 2x squared, a positive x, and a -11. So yes, this one is equivalent. Now, for number 6, you would have to move the 5 over by subtracting it and then compare to see if they're equivalent. So show what you get and a yes or no answer. All right, I want to jump down to number 7 with you. So in number 7, we're taking it a step further. We are not just graphing, we're graphing and solving. See how it tells us to solve here. So rewrite it in standard form. You cannot graph this because we need it set equal to 0. So the first thing I'm going to do is add 2 to the constant. This would give me a 0 equals, keep my x squared first, keep my positive 7x, and 10 and 2 adds up to 12. Now, this is standard form, but what am I really graphing? I'm graphing y equals x squared plus 7x plus 12. But since we're solving, we're trying to find x when y is 0. So this is what we're looking for, but we're using the y equals. And the reason I'm bringing that up is I need to take these x values and plug them in everywhere I see an x so I can get my graph. So we've done our standard form, we've done our graphing. The thing that's extra here, and I want you to write it underneath here, is I need to find what x equals. So I need you to add that little x equals with a box, because a lot of people are just graphing it and they're forgetting that, hey, we're supposed to solve it. Now, when I'm asking you to solve it, you're supposed to be finding the x-intercepts. Where does it cross the x-axis? We are trying to find x when y equals 0. That's our goal. Okay. Now, in order to put this in the calculator, I've given you the x values. If I didn't give you these x values, you would use that x equals -b over 2a, and you would find the vertex, and then you would build the numbers, but they're given to you. All right, you have your calculators with you? In your calculator, everywhere you see an x, you're going to replace it with parentheses. So we have a parenthesis and then -5, close it, power of 2. Plus 7, a parenthesis, -5 again, I'm just plugging in the first term, and then plus 12. Now be careful, you don't want to go back to the 10, you want to use our standard form. Okay, hit enter and I get 2. That's my first point. Now, to save myself time, I'm going to arrow back up and change out with the -4. And I get out 0. Okay, now I'm going to come back to this. I'm going to jump to the -3 because I don't have to change much. And I get 0. If you think about it, isn't that what I wanted? I wanted the x value when y was 0. Okay, I still need my -2. And I will tell you, on this worksheet, sometimes you get that reflection. See how we have the 0s and the 2s? But some of them don't give you that reflection because they're not spaced evenly for x's. So you'll still get a U-shaped curve, but it won't look as pretty in your chart. You can either retype it, or do you know you have that little insert key? So if I go in, I'm going to type in there's my -3, but if I type in 0.5, it's going to erase this. So hit second delete. See how it says second in the insert? See how it's blinking differently? Now I can put in my 0.5 and I still have my parenthesis. I'm going to arrow over. I'm going to change this from -2 to -3, and to insert the extra things, I put my second insert and then 0.5. Now, if you don't like that and that's going to mess you up, just clear it and redo the whole thing. So I have a -0.25. All right, so let's graph this. Remember, you're going x and then y. X is -5, y is +2. X is -4, y is 0. -3.5, 0.25 is just right below the line. -3, 0, and -2, 2. Okay, it's a tiny little parabola. It's your U-shaped curve. I have the arrows to show that it keeps going, but it's a U-shaped curve. If you're not getting that U-shaped curve, you're probably entering something wrong or you're graphing something wrong. So be careful with that. And I want to know, to solve the equation, I'm trying to find x when y is 0. And we already know that x is -4 and what else? -3 when y is 0. Do you see that those are the x-intercepts? -4, 0 and -3, 0. It's a little tight on that graph. So that's what you're doing. Now, flip your paper over, if you would be so kind. And underneath each of these where it says standard form, please go ahead and write x equals with a little line, because otherwise we're going to be turning you back saying you didn't solve them. So yes, put them in standard form, fill in the table, graph it, but you have that extra step of finding the x-intercepts. So under each of these problems, write your little x equals so you remember to give that final answer. Okay? And I'm going to remind you, not all of these are perfectly symmetric. So if you take a minute and look at some of these, they might jump around a little bit. So they might not be spaced the same. So if you look at this one, we have -1 and it jumps to -4, and over here it goes to 0. This changes by 1 and this changes by 3. So you're not always going to have that symmetry. So you do need to plug the values in to get y. You should still get a U-shaped curve if you connect the points. Okay, so the time is yours to work.